Lab 1 will be located approximately in this area here. This will be used as a laydown area for construction over here.
The Syracuse area, Central New York area is on the verge of this resurgence.
I don't see the applicant's representative.
I'm Ryan Pleskotch. I'm a town councilor in Clay. I've been on the town board since 2018, so I've seen a lot of preparatory change that's about to happen in the town.
Just 30 minutes north of Syracuse, Micron Technologies, a semiconductor industry leader, has chosen the town of Clay to house the United States' largest semiconductor fabrication plant project in United States' history.
When you build semiconductors, right, they need three things. They need space, because they're just massive facilities. They need water, and they need power.
Dr. Donald Hughes, an expert in chemistry, has lived in the area since 1985, around the same time when research began to reveal the harmful effects of a particular family of chemicals.
I learned more and more about the chemicals and PFAS, and the PFAS is pretty frightening. It's very toxic, and it's very persistent, and it accumulates in people's bodies. It accumulates in fish, it accumulates in our organs. All of us walking around have PFAS in our blood now.
PFAS, more commonly known as forever chemicals, refer to per- and polyfluoroalkyl substances. They're a family of over 15,000 different types of chemical compounds found in a variety of everyday products, including cosmetics, clothing, and food packaging.
No one is seriously taking the need to make sure that there are no PFAS released to our water bodies, like the Oneida River.
Traces of PFAS can also be found in the wastewater of chip fabrication facilities. The compound is critical to the fabrication process. According to Micron's draft environmental impact statement, Micron's off-campus wastewater treatment site is anticipating over 30 million gallons of wastewater discharge per day from the 4 fabrication facilities.
I mean, to me, that was a big lesson. Once you make a mess, you just can't clean it up.
The treated wastewater will be discharged into the Oneida River, which connects to Lake Ontario through the Oswego River. Exposure to PFAS are linked to a mess of serious health conditions like cancer and endocrine disruptions. Municipal wastewater treatment plants are not well equipped to remove PFAS, and the available methods and technologies for filtering PFAS at industrial treatment plants are limited. Even after Micron released their final draft environmental impact statement in November, how PFAS will be filtered from the facility's wastewater has not yet been clearly defined.
Last year, the Biden administration set very low limits for 6 common PFAS contaminants in drinking water.
The EPA says limits will stay in place for the 2 most common chemical types, but it's rolling back the rules on the others.
2025's rollback on the others means that the seemingly less toxic counterparts of PFOS and PFOA will not receive the same attention as before, creating even more concerns.
The industry has migrated to using very short chain ones, and there's a lot more of it, like hundreds of times more of it. And because of that, there's more toxicity. They're less toxic per unit, but there's much more of it.
Beyond treatment, detecting PFAS poses another set of challenges, and testing short-chain PFAS may be even more difficult than detecting the longer-chain types. In the Leam lab, about 15 miles south of the future Micron plant, researchers are working on technologies that might simplify and improve detection methods. And while they've been focusing on detection of long-chain forms, they say their methods could be easily adapted to detect other types of PFAS.
The conventional method is to use LC method, liquid chromatography. So for example, people get the sample from the site, they're gonna, those bring the sample to the laboratory, and then they measure the sample whether PFAS exists or not. It might take a couple of weeks. So it costs a lot.
Dr. Leem's lab is developing a device to detect PFAS using lignin, a waste product from paper manufacturing processes. Lignin's molecular structure can be altered to expand surface area, which expedites the device's ability to selectively detect certain types of PFAS.
Here we made a mesoporous platform that helps us to extend the surface area of the sensing ring. So on that mesoporous sensing platform, we have a molecule That's what Dr. Leem was talking to you about. It's a receptor molecule, it's a skeleton of that. So this will be installed on that mesoporous sensing platform, and that whole electrode will be used as a potential interface to detect PFAS.
Once research has advanced, devices like Dr. Leem's have the potential to be used by Micron. The company's final environmental impact statement claims that site-specific details will determine which treatment technologies will be used by the facility tasked with treating Micron's wastewater. The company has said construction is expected to start this year.
And talk.
This situation here is unique. We're the first semiconductor plant in the country that has had to go through an entire full environmental review. It could be a game changer that, okay, Micron is going to put in this technology, other companies should follow suit. The technology is in its infancy at this point. Some people are working at lab scale, some of it's gotten to pilot scale, some of it's, small commercial applications, but there's nothing big out there. This would be big and enable that industry to flourish.
While researchers are still racing against the clock to scale technologies for projects of Micron's magnitude, their shifted timeline has offered its own unique opportunities to further develop and prepare for the big changes semiconductors are going to power.